Hello everyone, in this video we are going to continue to look at calculating dosages for oral and parenteral medications, but we're going to add in some rules that we need to follow when looking at if it's safe to administer the medication after we've kind of done the math. There's some additional things we need to look at to see if it's actually safe in the real world in terms of nursing and administering that medication. So we're first going to look at oral medications, and these include tablets, capsules, and liquids. Okay? So we looked at this question in the last video, but I want to look at it again and apply some of the rules we're going to be talking about. So the order is 3/4 of a grain of medication, and the tablets that we have available are labeled as 90 milligrams, and I've written there that 1 grain is 65 milligrams. So if we're looking at doing this in our ratio proportion method, and we have available on one side and ordered on the other, then we're going to, on the first side, available to us is 90 milligrams in 1 tablet. Now we can't put the 3/4 grain in there yet because we need them to be the same unit, and generally we like to convert them to the unit of what we have available. So we're going to take the 3/4 grain, and I'm going to use dimensional analysis and our conversion rate. So I'm putting the 1 grain on the bottom and the 65 milligrams on top. So in my calculator, I'm going to do 3/4 times 65, and that gives us 48.75. So in here, we're going to put 48.75 milligrams. How many tablets is that? Okay, so I have to do that conversion before I can actually compute how many tablets it is. Now I can do my cross multiplication, which gives me 90x equals 48.75 milligrams. And then I'm going to divide by 90, and I get x equals 0.54166 repeated. So because this is a tablet, I either have to do a full tablet or a half tablet. So I'm going to round this to 0.5 or half a tablet. So let's look at the rules and see if there's any issues with how we have computed this math out. So the first thing is that only scored tablets are intended to be divided, and it's actually safest if you can leave them whole. So if possible, we want to give 1 whole tablet, but if they're scored, we can cut them in half. So let's look at our question. It doesn't say anything here about this tablet being scored. So the first problem is that the tablet is not scored. So if we're looking at what's available to us, these 90 milligram tablets, that is not going to be safe because we can't actually split that into a half tablet. Okay, and obviously we don't want to give them a full tablet because that's going to be too much medication for them. So the first issue is the tablet's not scored. Capsules cannot be divided as they're only available in whole amounts. That doesn't apply to this question, but that is another rule. Capsules cannot be split in half because they're the ones that have the coating and then either like a liquid or a granule or something like that inside of them, and so we can't split them in half at all. When the precise number of tablets or capsules is unrealistic, like 0.54, which is what we had there, you cannot have no more than a 10% variation between the dosage ordered and the dosage administered. So whenever you're rounding, you have to look at how you have rounded and how much medication that's going to give them, and it can't differ by 10%. So basically what that means, if we look at that here, if we do half a tablet, how much medication are they actually getting? So half a tablet is going to be equal to 45 milligrams of medication. Now in this case, what was ordered, we worked out to be 48.75 milligrams. So is that within 10% of what was ordered? Okay, so 10% of 48.75, we can times that by 0.1 or 10%, is going to be 4.875, which means that if what I have ordered is 48.75, I can go up or down by 4.875 and it still be within 10% of what was ordered. So if we go up, so 48.75 plus 4.875, we get 53.625, and if we go down, we get 43.875. So that means, so this 10% variation rule means I'm going to take what was ordered, which in this case was 48.75, and I'm going to find 10% by multiplying by 0.1, and I get 4.875. And then I'm going to add it and subtract it to figure out the safe range. Okay. Now in this case, 45 milligrams or half a tablet would be within that range, so that is a safe rounding. So if this tablet was scored, then giving half a tablet is within that 10% range and is therefore would be safe. So far the only problem with our rules is that the tablet is not scored. The next rule there is tablets and capsules may be available in different dosage strengths. So if you have a couple different dosage strengths available to you, then you want to choose the strength that will allow for the least number of tablets or capsules without breaking. So whichever one is going to give you the least number of tablets and the least number of whole tablets would be the best one, the best strength to choose. And also keeping in mind that the maximum number of tablets or capsules to give to a client is usually 3 in one dose, although there can be exceptions, but the general rule is that no more than 3 in a sitting. And for oral prescriptions that require fractional dosages, we want to state our answer in fractions. So just like we did here, I didn't keep it as 0.5, I wrote it as half a tablet. Okay, so looking over all of those rules and what we've calculated as half a tablet, the only rule that we're kind of having an issue with is the fact that it's not a scored tablet. Other than that, it's not a capsule, so I don't have to worry about it being divided. We looked at our 10% variation. It was within 10%. We only have the one dosage strength, so we don't need to choose between any specific ones. It's not more than 3, and we have stated it as a fraction. Okay. For more information on this, you can go to page 297 in your text, but we are going to do some more examples. Okay, so let's look at another example here. So we have another medication here, 210 milligrams PO by mouth at bedtime, PRN, or as needed. So again, remember this means by mouth, and this means as needed. And available to us is capsules labeled 100 milligrams. So the first thing that comes to my mind when I see capsules is I'm thinking about our rules that have to do with capsules. The main one being you cannot split a capsule. So I know that when I come to my answer, it's going to have to be a whole number. Okay, so that's the first thing I'm thinking about. So looking at what should the nurse administer? So again, we're doing available to ordered. So available to us is 100 milligrams in one capsule. And what is ordered is 210 milligrams. How many capsules? So I'm going to cross multiply, and I get 100x equals 210. Then I'm going to divide by 100. I get x equals 2.1 capsules, which I know because it's a capsule and cannot be split, I have to round to 2 capsules. Okay. The next question is that safe? Well, I've given a whole capsule. I haven't split it, so that's fine. So this one, tablets don't apply here. Capsule cannot be divided. We did that. The next one is that 10% variation because I've had to round. So let's check out 10% variation. So the first thing I need to figure out is how much medication am I giving them if I give them 2 capsules. So 2 capsules at 100 milligrams a capsule gives them 200 milligrams of medication. Okay. What was ordered is 210 milligrams. I need to figure out what my range is. And we always figure out the range based on what was ordered, not based on what we're giving them. We want to make sure that what we're giving them is within the ordered range. Okay, so I'm looking at what is ordered and I want to figure out that range. So 10% is going to be 210 times 0.1 or 21 milligrams. So we can go up or down by 21 milligrams. So that means that my range is going to be 210 plus 21, which is 231 milligrams, and 210 minus 21, which is 189 milligrams. So that means my 10% range is between 189 milligrams and 231 milligrams, which what I've given them, 2 capsules of 200 milligrams, is within that range. So we can say, therefore, it is safe because it is within 10%. Okay, now let's just check our other rules to be sure. So the 10% variation was okay. When choosing different strengths, we didn't have a different strength to choose from, so that's fine. It's not more than 3, so that's okay. And it wasn't fractional, so I can write it as a whole number. So that's good. So I've hit all of my rules there. Therefore, I know it is safe. Okay. In this question, we have another medication, 7.5 milligrams PO by mouth at bedtime. And we have 2 different tablets available. They are scored, which is telling me that I can have half a tablet, right? And we have 2.5 milligram tablets and 5 milligram tablets. So it's saying, which strength should we use and why? So what I'm going to do is figure out how many tablets I would have to give them for each one, or if I do a combination of them, to see what gives me the least amount of tablets, or with the amount of tablets without breaking, and that follows obviously our other rules. So let's start with the 2.5 milligram tablet. So available to me is 2.5 milligrams per tablet, and I have ordered 7.5 milligrams. How many tablets? So I'm going to cross multiply, and I get 2.5x equals 7.5, so x is 3. If I use the 5 milligram tablet, I cross multiply, and I get 1.5 tablets. So far between these two options, the 2.5 milligram tablet might be a better option because we're not having to split tablets, and it's still no more than 3 tablets. It's also giving me the exact amount ordered. The 5 milligram tablets does give me the exact amount ordered, but I have to split them. They are scored, so I could. But let's look at a third option. What if we were to do one of each? So if I do one 5 milligram tablet and one 2.5 milligram tablet, I get 7.5 milligrams right on. That gives me 2 tablets in total, and I'm not having to split. So that would probably be our best option, was to give one of each. So 1 5 milligram tablet and 1 2.5 milligram tablet. Again, that gives me 2 whole tablets, exactly what the doctor ordered, and I'm not having to split any. So that would be the best option. Let's look at this next one. So this one, we have 1.5 grains by mouth at bedtime, and available to us is 15 and 30 milligram tablets. It doesn't say anything about them being scored, so that means I'm going to have whole numbers again. It wants to know what is the appropriate strength of tablet to use and why. Well, the first thing I need to look at is what is the grains to milligrams, and again, 1 grain equals 65 milligrams. So let's do that conversion first. So 97.5 milligrams. So let's look at the first tablet we have, which is 15 milligrams. 97.5. I'm going to cross multiply and divide. And that gives me 6.5 tablets, which I can't do a half, and 6 is way too many. So that's not a good option. Let's see what the 30 milligrams tabs does. Cross multiply. is 3.25, which we'd have to round to 3 tablets. Okay, so of these two, so far it looks like the 30 milligram tablet is the better option. Okay. The next question is how many tablets would we administer? So we've kind of done that math there. So I would administer 3 tablets. Okay. We could say 3 tablets of the 30 milligram tablets, and then is that safe? So again, looking at our rules, it's a whole tablet, we haven't split it. It's 3 and less, so that's fine. The other main one is that variation. So let's just double check that the 3 tablets keeps us within that 10% variation. So we have suggested 3 tablets at 30 milligrams, gives us 90 milligrams of medication. And what was ordered when we did that conversion was 97.5. So we need to make sure that 90 milligrams is within that 10% variation. So 10% equals 97.5 times 0.1, which equals 9.75 milligrams. So that means I can do 97.5 plus 9.75 is 107.25 milligrams, and I can go down by that much, so 97.5 minus 9.75 is 87.75. So my 3 tablets, the 90 milligrams is within that range, so it is safe. Okay, again, let's just double check our rules up here. Scored tablets are intended to be divided. We're using whole numbers, so that's okay. It's not a capsule. It is within 10%. We want to choose that have the least number of tablets, which is what we did. Maximum is 3. That's fine. And again, we're a whole number, so we didn't have to worry about putting it in a fractional dose. So we've hit all of our rules there. Okay, looking at parenteral medications. Now, these are medications that are delivered by any other route in the digestive system than the mouth. So usually it's an injection with the use of a needle and a syringe into body tissue. So intramuscular, subcut, intradermal, or intravenous. Okay, so any of these variations. Now, when you're looking at these types of medications, rather than looking at whether you can split a tablet, capsule, all of that, what we're looking at is what syringe are we using? Rather than rounding to a full or a half, we're looking at rounding based on the calibration of the syringe that's being used. So for example, if we're using a 3 milliliter syringe, then it's in tenths. And if it's a 1 milliliter syringe, then we're rounding to the hundredth. So it depends on what the markings are on the syringe that you're using. Right? Now again, when we've rounded, we still need to check that 10% variation to make sure that we are not giving too much or too little of a medication. And generally, if it's done through an injection, we need to really be careful with the strength of the medications that we're looking at. Okay, so let's look at an example. So a dropper is calibrated to give 10 milliliters a drop. So when we're looking at rounding, we're rounding to the 10 milliliters of a drop, right? The vial the patient is taking has a dosage strength of 5 milligrams per milliliter. Provided the patient is required to receive 150 milligrams per dose, how many drops do they require, and is that safe? Okay. So again, looking at that available and the ordered. So available to us is 5 milligrams per 1 milliliter. Okay. And ordered is 150 milligrams. We need to figure out how many milliliters that is. Now I know it says how many drops, but we first need to figure out the milliliters, and then we can go from milliliters to drops. Okay, so I'm going to cross multiply, and I get 5x equals 150, and then I'm going to divide, and I get x equals 30. Okay, so 30 milliliters. Now I'm going to take that 30 milliliters and put that into drops. So a lot of you again can just look at this number and know, but I'm going to show you the math just in case it doesn't work out as nice as this one does. But we're looking at, again, available to us is 10 milliliters in a drop, in one drop. We need 30 milliliters. So how many drops? So you almost need to do it twice. And again, some of you can probably look at this and say, well, I know exactly how many drops, but I'm just showing you the math in case it's not as easy to see. Okay, again, I'm going to cross multiply here, and I get 10x equals 30, so x equals 3. Now, to determine whether it's safe, we're looking at that 10% variation here. We're not splitting capsules or tablets or anything like that. And there's not sort of like a 3-tablet rule here because it's a liquid. But what the rule that it's mainly focusing on for is it safe is it within that 10%? Now with this question, we didn't have to do any rounding. The drop worked out perfectly. So the 3 drops we're giving them is working out to give them exactly what the doctor ordered. So we don't need to worry about the 10% variation. So it is safe. So therefore, it is safe because 3 drops gives them exactly what the doctor ordered. Okay, I want you to try this one. Pause the video and then start it up again when you're ready. Okay, so a dropper is calibrated to give 2 milliliters a drop, and the vial the patient is taking has a dosage strength of 5 milligrams per milliliter. Provided the patient is required to receive 20 milligrams per dose, how many drops would they require, and is this safe? Okay, so again, available to us, the dosage strength is 5 milligrams in 1 milliliter. And the doctor has ordered 20 milligrams per dose. So how many milliliters is that? We're going to cross multiply, so I get 5x equals 20. X equals 4 milliliters. And then I'm going to take that 4 milliliters and I'm going to see how many drops that is. So 2 milliliters is 1 drop. 4 milliliters is how many drops? 2x equals 4, so x equals 2 drops. And again, that is going to be safe because it's giving exactly what the doctor ordered. Now let's say that your answer here got you, 2.2 drops. You're going to round to 2 drops, right? But now you need to figure out that 10% variation. You're then going to look at, well, how much medication does 2 drops give? And then, so how many milliliters is that? Therefore, how many milligrams is that? And then you would look at that that 10% variation. So you would go, okay, so 2 drops times 2 milliliters a drop is going to give you 4 milliliters. 4 milliliters times 5 milligrams a milliliter gives you 20 milligrams. And then you would look at, what was ordered and if that was within 10%. Okay. The other unit you might be asked to do is to give the patient by teaspoon. Because if you are prescribing it to the patient, they're taking it at home per se, then you need to put it in a measurement that they're going to get at home. So whether that is milliliters or whether you're going to give that in teaspoons. Okay. So the order for this is 0.5 grams by mouth every 4 hours for 10 days. Okay. And it wants to know how many teaspoons must be taken by the patient each day if we have available to us 250 milligrams per 5 milliliters. So we've got a few different units here. We've got grams, milligrams, milliliters, and teaspoons. So let's work through this. So the first thing I want to do is set up my available versus ordered ratio. So available to us is 250 milligrams per 5 milliliters. Now ordered was 0.5 grams. I'm going to put that into milligrams because we always want to work in what's available to us. So 0.5 grams is going to be 500 milligrams. Again, you can think of it as on our metric scale, we have grams, decigrams, centigrams, milligrams. So to get from grams to milligrams, I'm going to times by 10, 1, 2, 3 times, which gets me to 500 milligrams. Okay, so 500 milligrams is how many milliliters? I'm going to cross multiply, get 250x equals 2500, and therefore x equals 10 milliliters. Okay, so they need 10 milliliters. They're asking, well, what is that in teaspoons if 1 teaspoon is 5 milliliters? So there's, again, lots of different methods you can use to do this. I'm going to use dimensional analysis. So I have 10 milliliters, and I'm timesing that by 1 teaspoon and 5 milliliters, and I get 2 teaspoons. Now, is that the end of my question? Is that the answer? My patient needs 2 teaspoons each day? No, that was by dose. That was 2 teaspoons per dose. I need to look at how much they need each day. So if you look at the original order, it's every 4 hours. So 24 divided by 4 is 6 times a day. So I'm going to take my 2 teaspoons, times it by 6, and I get 12 teaspoons per day. So quite a few different steps to this question. It looked like a basic question, but because of all of the different conversions and asking for each day, there was quite a few different little steps in there. So we first had to convert to milligrams. Once we found out how many milliliters there was in each dose, we then converted that to teaspoons, and then we had to times that by 6 to figure out how many teaspoons per day. Okay, try question 2, pause the video, and then start it up again when you're ready. Okay, so a liquid antibiotic is to be given at home if the patient is to receive 75 milligrams per dose and the bottle is labeled 5 milligrams per milliliter. How many teaspoons will the patient need each dose? Okay, and again, 1 teaspoon is 5 milliliters. So the patient needs 75 milligrams per dose. The strength we have is 5 milligrams in 1 milliliter. So we need to figure out how many milliliters that is. Cross multiply, we get 5x equals 75, or x equals 15 milliliters. We need to now put that into teaspoons. So 15 milliliters is 1 teaspoon per 5 milliliters. Tells me 3 teaspoons per dose. Okay. And a last question here. We're looking at this picture, and we have a couple questions we need to learn about it. So what is the total volume of the vial? We're looking at this picture, and we can see that right here. So 10 milliliters is the whole volume of the vial. So the dosage strength is here. It can be easy to mix those two numbers up. So remember, a strength is going to give you the amount of medication in a certain amount of the liquid or the tablets or what have you. So there's going to be sort of 2 units there versus just the 1 unit. So the dosage strength here is 0.1 milligrams per milliliter. The route of administration is injection. Okay. And now it's asking, if 750 micrograms was ordered, how many milliliters would you administer, and is this safe? Okay, so again, what is available to us is 0.1 milligrams per milliliter. Okay, and that equals 750 micrograms. So again, we want to put it into what is available to us. So if we're looking at our metric scale, we have milligrams, 2 other units in there between milligrams and micrograms. So to go from micrograms to milligrams, we're going to divide by 10 1, 2, 3 times. So that means we have 0.750 milligrams. How many milliliters? I'm going to cross multiply, get 0.1x equals 0.75. So x equals 7.5 milliliters. So the next step there is it safe? We don't have quite enough information here to determine if it's safe. It would depend on the syringe that's being used. But let's say that we're using a syringe that's accurate to tenths, then it would be safe because 7.5 milliliters gives us exactly the medication that we need. If it was a syringe that was accurate to the nearest milliliter, let's say, then we'd have to round this to 8 milliliters, and then we'd have to determine the 10% variation and whether that fits within the calibration of the syringe and what's actually been ordered. Okay, so we're actually going to look at two more questions that have to do with the accuracy of the syringe in this. So I want you to try these two questions, determine how many milliliters is administered per dose, and then given the accuracy of the syringe, is this safe? So pause the video, try them out, and start it up again when you're ready. Okay, so question number 4 here. We've got heparin, and we have 5,000 units subcut BID, that means twice a day. Available to us is 20,000 units per milliliter, and the syringe is accurate to hundreds. So how many milliliters would we need to administer per dose? So again, available to us is 20,000 units per 1 milliliter, and it ordered is 5,000 units. How many milliliters is this? So we're going to cross multiply. So that should be 20,000x equals 5,000, and then we're going to divide, and I get x equals 0.25 milliliters. The syringe again is accurate to hundredths, so yes, this would be safe because we haven't had to round past the hundredths. So therefore, yes, it is safe. Again, because it's giving the exact amount of medication, we haven't had to round this at all, so it's going to give them exactly what the doctor ordered. Let's look at question 5 here. So available to us is 15 milligrams per 1 milliliter, and ordered is a quarter grain IM every 4 hours and as needed. So we need to put that grain into milligrams. So we're going to do 1/4 grain times 1 grain being 65 milligrams. And I get 16.25 milligrams. So how many milliliters is that? I'm going to cross multiply and divide, and I get 1.083 repeated. Now our syringe is accurate to hundredths, so I need to round this to 1.08 milliliters. So now we need to determine if that rounding was safe to do. So to do that, I'm going to take my 1.08 milliliters and figure out how much of the drug is that actually giving them. And it is giving them 15 milligrams per milliliter. So I'm going to times by 15. And I get 16.2 milligrams is what I'm actually giving them. Ordered was 16.25 milligrams. So 10% of that is going to be 1.625 milligrams. So that means I can go up to 17.875, and I can go down to 14.625 milligrams. So the 16.2 is within that range, so therefore, yes, it is safe because it is within 10% of what was ordered. Okay, so again, looking at our rules and the different things that we've talked about today, the calculations are the same, but what we've added in this lesson is really looking at the rounding and how that applies to the rules. So when looking at tablets or capsules, you want to make sure that when working with tablets, you can only round to a whole number or a half number if it is scored. Okay? If it's scored, it's intended to be divided, so you can do a half number. Otherwise, you'd have to round to a whole number. If it's a capsule, you have to round to a whole number because they cannot be divided. When doing that rounding, you then need to make sure that what you're giving them is not more than 10% above or below what was ordered. If you have to choose between different dosage strengths, you should always choose the strength that allows for the least number of tablets or capsules without breaking, or the one that gives the most accurate or exact amount. So you always want to get as close to what was ordered as possible in the least amount of tablets or capsules without breaking. The maximum number of tablets or capsules you should give in one dose is 3. And if you do have to do a half tablet, make sure you're writing that as a fraction and not as 0.5. When it comes to liquids, so whether that be an oral liquid or a parenteral medication, it depends, what you're rounding to depends on how you're giving that medication. So if the syringe is to the nearest 10th or to the nearest 100th, or it's by drop, then that is what you're rounding to. And again, you're checking that 10% variation to make sure that however you're rounding isn't going to be more or less than what has been ordered, or 10% of what has been ordered.